Okay, so let's have a look at this one. This is a question about moving stuff up a slope, question 34. And the thing about this is that you're going to want to try and use probably something like the change in potential energy. And you'll try and work out whether the change in potential energy of this guy as it moves through 2 meters is going to be the same as this as it moves through. Well, it's going to move 2 meters because it's attached to the same rope or the same cable, but it's only going to move against gravity a smaller distance. We're going to find out what that distance is. Right, okay, so the box is mass 50 kilograms. The student claims the efficiency is greater than 90%. The machine uses a slope of height 2 meters and length 15 meters to move the box. The box was connected to an 8 kilogram mass by a rope over a pulley as shown. As the mass fell, the box moved at the slope of steady speed. Okay, so let's have a look at the change in potential energy. The change in potential energy, mgh, is equal to, of the small mass, is 8 kilograms times 9.81 newtons per kilogram times the 2 meters. So this potential energy, let's do this on the calculator, equals 8 times 9.81 times 2, which is equal to 156.96 joules. Okay, so then we're going to look at the change in potential energy of this box, the 50 kilogram one, which moves up through a small distance. Now we have to find this distance. How are we going to do that? Okay. Well, let's work out. If this is 2 meters and we can work out what the angle is, then we can work out what this height is there. So first of all, let's use the bigger triangle, the 15 meter hypotenuse with a 2 meter opposite angle to find this angle here. Theta. So we can say that sine theta is equal to 2 meters divided by 15 meters, which means that theta is equal to sine to the minus 1 of 2 over 15. So let's find out what theta is equal to. And theta is equal to, we have to find out, we don't actually need to do this because we can leave it as a fraction, but anyway, let's do it anyway. 2 divided by 15, and we will do the inverse sine, so we get theta is equal to 7.66 degrees. And then we can say, okay, well, I wonder what the vertical height is here. Now we have the hypotenuse, so we've got a smaller triangle with only 2 meters there, and we've got this h, and then we can say, but we know theta, so we can say that sine theta is equal to h over 2 meters, or we can say that this height is equal to 2 meters times sine theta. Now we've already worked out that sine theta was 2 over 15. So we can do, if we want to, we can say that h is equal to 2 meters times 2 over 15, which is equal to 4 divided by 15, which is equal to 0.26 meters. So then we've got the potential energy gain in potential energy is equal to 50 kilograms times 9.81 newtons per kilogram times 0.26 meters. And then this is equal to, putting all this together, equals 130.8 joules. So the useful energy we got out, useful, was the potential energy that the block gained, which is equal to 130.8 joules, and the total energy, or the input energy, was equal to 156.96 0.96 joules. So if we say that as a percentage or a fraction, so we should find that we get about 83%. About 83% efficient. Now, the student reckoned that it was greater than 90%, so we're going to say that it isn't. So 83% is less than 90%, so student is wrong. Okay.